There are several things that we do already with IoT. As I mentioned earlier, we provide tools so that our customers can build smart devices. And these nodes, so-called, are just smart devices for IoT. We also provide tools for the analyst over here. And so we add more functionality for analytics, such as machine learning techniques. They are not only for IoT, but they are very important to IoT. And when we have MATLAB, our technical computing environment on the analyst side, they have the ability to move their programs up to the cloud. So we do support cloud. We have tools that enable our users' programs to run on Amazon AWS, for example, or close to an aggregator of data. This functionality is not only for IoT, it's useful for anyone who uses cloud computing services. So I have been with MathWorks for about 26 years, and I take the long view. When we look at IoT, we do not see a situation that requires different tools. What we see is how to evolve our tools so that the people who already know how to use our tools can use this type of structure. So it's evolution, not revolution. Things like IoT and cloud do introduce some new technical concepts, so we make sure that we support those. But still MATLAB, still Simulink. When you think of mission critical, I think of the development process. And so the first question is, do I have the right idea? Right? And from a mission critical standpoint, the question is, am I designing the thing that will solve the problem? Because it's a mission critical problem that this has to solve. And so when we talk about model-based, that means being able to create the idea of what you need to solve or create the idea of what you need to build very early on with simulation. And so simulation is critical toward making sure you have the right idea, the right concept. Because if you just write it down as a document, you don't know if you can build it, and you don't know if it solves the problem. So you must model and simulate your ideas to make sure that you have the right concept. And so we think of this phase as being the design phase, right? Trying to think of what I have to create and designing it. The next part is implementation, to build it. And there we have technology for automatically generating the code. Which means you have the model, you get it right in the model, you push a button and the code comes out. And that reduces error because manual programming often requires interpretation, which can be an error, or it may be a manual coding error. And so by automatically generating code, you eliminate the errors at implementation. And that's also important for a mission critical application. And then the other key piece is a set of tools for being able to test and verify that you've built it correctly. And so That's also part of the process, and we have tools for doing that as well. You get verification feedback very early, but you also are able to verify the final product before you ship it. Of course, these are all products and tools. But to help an organization to address mission-critical applications, there are other things that are necessary as well. Making sure that there's strong training so that the people use the tools correctly and know what they're doing. You also need support. You also need consulting. If they get stuck, help them around the problem. And so the organization that we have in Korea and around the world is a necessary part in supporting mission-critical applications also. You mentioned a competitive situation. There may be a product or a tool from another company that does a piece of it, or does another piece of it. And then it requires the customer to put it all together. And that can lead to problems. And so having one organization, we know how to connect other tools to ours. So it's not only MathWorks products. We also interface and integrate with other products from other companies. But we know that stuff, and we do not push it to the customer to try and integrate it themselves. One aspect is to make sure that the middle schools can have the easy way to access the products. And so we have an offering for middle schools that we make available in Korea and actually around the world. A second piece of that is to provide resources, tutorials, examples, and to help make sure that the middle school teachers are comfortable using the software in their courses. That's one piece. I understand that the Korean government places a strong focus on coding and programming as a skill for any student to have. And we agree with that. So we support high schools around the world. This is a girl high school in US. And for her, programming in MATLAB is great because it helps you to teach to think in a logical way. And that's my understanding of how the Korean government views that problem also. And MATLAB is an attractive language for learning programming because it is forgiving, and you do not have to worry about some low-level programming constructs like other languages. That's always been the beauty of the MATLAB language. But some students in middle school will go into engineering or will go into science. And learning coding is low level. It helps you think logically, but it is not the way engineering organizations or scientific organizations work today. They work at a more abstract level of thinking. So the second piece, beyond programming, is to help the educational universities and schools help teach their students to use more abstract techniques, because the types of problems that they will have to solve when they work are complex and require that abstraction. So that's the second piece, is tools to help the educators to teach more abstract concepts. When a student learns how to program, they learn the logical thinking. But it only becomes interesting when the program does something interesting. And being able to work with low-cost hardware, like Arduino or Raspberry Pi, when you program that type of low-cost hardware, then the student becomes more interested because it actually does something, right? And so we make sure that there are support packages for low-cost hardware that are just available. And students can download, people in industry can download. And they can play with ideas and they can be interested by the ideas. So that's a key part of the engagement for someone who may be ending up as an engineering student or a science student. And sponsoring the hands-on experience of students. So competitions like the Smart Car Challenge that's held here is a very useful way to get students working as teams and working on real stuff that's hands-on and determining whether their idea can actually work. And so we sponsor and support these types of competitions.
그리고 또 이제
Absolutely. I think we are interested in working with hardware vendors who are building educational boards to support them. Our approach is driven by the market. So on MapWorks' website, there's a page where anyone can go there and say, please support this board X, please support this board Y. And the most popular requests get acted on. And so we listen to the market, and we also work with companies like Analog Devices and Xilinx and Altera and many other hardware makers to support initiatives.